Avionics Electronics EMC webinar. Thank you for joining us. This webinar is being given by MET Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, Korea, and Italy. This webinar will run 30 to 45 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your GoToWebinar control panel. We will attempt to answer all questions at the end. Just a quick note on our other upcoming events. On the 11th, we're hosting a railway electronics webinar, and on the 16th, we're hosting a safety certifications for sign shops webinar. You can get more information online. Today's webinar is being presented by Assad Bourgeois. Assad is MET's EMC Lab Director, and at this point, I will hand over the presentation to Assad.
Thank you, Sarah, and welcome folks to our webinar. As Sarah mentioned, we're going to cover RTCA DO-160 with a focus on RevG, and we'll be talking about the commercial aircraft avionics testing with a special focus on the electromagnetic aspect of the testing. As you folks may know, the DO-160 covers both environmental and the EMC, EMI aspect of the commercial avionics. My focus today would be to cover the sections of the standard which would be related to the EMC and EMI, which are predominantly from section 15 to 23 and then section 25. The rest of the sections are more related to the environmental aspects of the testing. The intent of this presentation is to cover the EMC section of the standard, as I mentioned, with a focus on the test methodology, how would it apply to different products, talk about some of the challenges, and also go over some of the updates with the RevG. In a nutshell, it's a kind of introduction of the DO-160, especially for the folks who are new to the DO-160 testing. Here's a brief outline. As I mentioned, we'll cover various aspects of the DO-160 with the focus on the EMC, EMI. We'll talk a little bit about which committee of the RTCA is more responsible for the standard updates and standard changes. We'll cover the test requirements. We may not have time to cover every single test method in the standard, even within the realm of the EMC requirements. We'll focus on some of the key sections which are more relevant to this discussion, including a little bit more focus on the lightning-induced transients, which is the indirect light flow. The DO-160 or RevG, which basically covers environmental conditions and the test procedures for the airborne equipment, was prepared by RTCA Committee 135, and this RevG was released in December 8, 2010, which supersedes the RevF. This particular document covers the standard test procedures and environmental conditions for testing airborne electronics. The tests specified in DO-160G are typically performed to meet the FAA or other international regulatory bodies requirement. Some of the test methods are virtually very, very similar to the requirements for the European counterpart. Just to draw a quick parallel, and I have a brief slide to go with that as well. There are many of the requirements which of the DO-160 are similar to the European counterpart of the standard, which is basically covered by the EuroKit. As I mentioned, this document contains many sections, total of 26. The section 15 to 23 are the sections which are relevant to EMC, EMI, and section 25, which is the ESD testing, is also covered by the EMC group here. Let's continue our discussion. Before we jump deeper into what the standard talks about in terms of the EMI, EMC requirements, let's see what we call avionics. Traditionally, avionics was considered to be more something with the navigation and the communication. However, with a growing trend in the industry where everybody is trying to go more towards electromechanical system, whether we talk about, just to draw a parallel in the vehicular environment, similar trend we see for the larger part in the commercial aircraft industry, where folks are going with the design which are more and more electromechanical, and so by very definition, practically anything could become avionics when it's airborne, whether they're engine control, servo motors, controllers, we talk about landing gears, radar, Wi-Fi systems we see on commercial aircraft, which are becoming more and more popular these days. Satellite or other entertainment system, they are also being seen, especially on the longer flights. So all of these equipment would have to go through some level of testing based on how severely they could degrade the performance of the other electronics on the commercial aircraft, and or how essential they are for the safe operation of the aircraft itself. I mentioned briefly that DO-160 is prepared by RTCA, which is the Radio Technical Commission for Aeronautics. The subcommittee 135 is predominantly responsible. The latest rev, which is G, came out in December 8, 2010. Typically, we see every 3 to 4 years, not more than 5 years go by, and we see a new release of the standard. The release G came with a special focus on the section 22, where they added a new user guide with some other changes along the line. Okay, EuroCAD is an organization which is responsible for civil aviation equipment in Europe. If you look at their publication ED84, that is practically the same as section 22, which covers on lighting. So if we compare the European requirements with the DO-160 requirements, we find a lot of parallels. In some cases, we see the requirements are practically the same. When we talk about the commercial aircraft testing, the point comes to mind how much it differs with the military aircraft testing or military testing in general. The military standard, as you folks may be aware of, that is covered by the standard like MIL standard 461. The latest release is 461F. There have been talks in industry going for quite some time that the commercial aircraft as well as the military aircraft both should be subjected to, or if you allow me to take a step back, both would be in many cases exposed to similar threats when it comes to the indirect lightning, or in some cases the ESD-like phenomena. So there have been discussions going on for quite some time to incorporate some of the aspects of the DO-160 testing into 461 standard. Those efforts are going on for quite some time. We start hearing about these things. I personally participated in many of the meetings where the discussion focus was to incorporate the lightning, indirect lightning, and perhaps some aspects of the ESD testing into the 461. The thought was these things will be incorporated with the Rev G. However, for one reason or other, the release of Rev G has been delayed several times, and we are hearing again that perhaps it will be released sometime soon, most likely in 2015. Originally, the thought was this thing will go in play in 2012, but it has already been significantly delayed. So see how this thing transpires, and if that happens, then we'll see a lot more parallels between the commercial aircraft testing and the military testing on the military aircrafts. A brief summary of the requirements. As I mentioned already, that there are 26 sections with the current document of the DO-160. There are 26 sections with DO-160. The section I have listed on this slide, they are predominantly the one which cover the EMC and EMI aspect of the testing. Just to name a few, section 15 covers the magnetic effect. The section 16 covers the input power requirements, voltage spikes, so on and so forth. As I mentioned, we may not have time to go over every single test method due to the restriction of the time, I will try to cover as much as I could and try to explain the test methods and some of the caveats which we use during the testing, and if time permitting, we'll go over some of the debug techniques which will be applicable if during the testing the products go into some non-compliance issues. So section 15, which is basically we are looking for magnetic effect. The way the testing is conducted is quite a bit different from any commercial magnetic susceptibility or magnetic immunity. If we look at the European requirement, the standard there is IC 61004-8, which talks about the magnetic immunity testing. The idea there is to immerse the product into something like a Helmholtz coil and then see if the device will operate when a magnetic field is present, assuming the device will have some magnetic sensitive components. However, with this particular test under section 15, the intent is entirely different, where the idea is to see when a device is mounted or installed in a commercial aircraft, would the magnetic field, if any, generated by that device could cause a deflection into the instrumentation being used on the aircraft in any way, shape, or fashion. So the way this particular test is done, typically a test laboratory would use a magnetic compass, move the EUT from, for example, east to north, and move the EUT from the compass in a fashion that there is a 1 degree deflection from the North Pole indication on the compass, and that will tell what is the safe distance for this given device under test to be installed from other sensitive instrumentation on the commercial aircraft. There are various different categories. Typically, in this case, there are 5, which are based on the safe separation distance, which can be from 30 centimeter all the way up to the 300, all the way up to the 300 centimeters. The next test I want to go over is the basically section 16, which talks about the power requirements on the input power. By the very definition, the input power is quote unquote not an EMC or EMI test. However, considering that large number of laboratories in USA will be the one who will be dealing the power input or power quality testing, and some of the frequency ranges which are used during the some of the tests for section 16, which include the frequency variation and whatnot, as they fall into the domain which is covered by the EMC. So most of the time, these tests, which are called power input or power quality, they would be covered by the EMC segments of the laboratory. The intent, the idea of this whole test is on the power input is to see when there are various phenomena on the power line, when there's a variation in either in the amplitude or in the frequency on the input power, how would it impact the performance, or would it cause any degradation of performance? And conversely, the idea there is to see when a device is connected to the aircraft bus, could it negatively impact the operation of other devices which are installed on the same bus on the commercial aircraft. The next one I want to cover is section 17, which is basically the voltage spike. The whole idea there is to see on the power buses, or in general, when there are a lot of electronics in a given environment, due to the switching mechanism, due to the nature of the inductive loads, there will be voltage spikes present, and the idea there is to see when those voltage spikes find their way into the EUT, could that negatively impact the performance or cause degradation of operation of the given avionics equipment. So thereby, based on various statistics, the folks came up with the idea of this voltage spike test, which is based on 10 microsecond duration with 2 microsecond rise time, and with a source impedance of the 50 ohm. This test is very, very similar to CS106, which is called out by the MIL standard 461F. So if with the application of this pulse, which is applied for 50 volts at least for the duration of 1 minute, if the device and the test continues to operate as intended, it's deemed that it meets the specification. The next one which I would like to cover is Section 20. Section 20 in a nutshell covers radio frequency susceptibility and the conductive susceptibility. The test method is very, very similar to some of the MIL standard 461 requirement, where the conductive susceptibility part is fairly similar to the MIL standard test method CS114, and the radiated susceptibility test method is very, very similar to the RS103. There are minor deviations. For one, if we look at radiated susceptibility, the frequency range goes only up to 18 gigahertz for DO160, whereas for MIL standard 461, the frequency range could be as high as up to 40 gigahertz, depending upon what the application of the EUT is and what sort of the clock frequencies are present, which are there as part of the EUT's operation. The another thing is that the MIL standard test levels are the max out as 200 volts per meter for the entire frequency band, whereas for the DO160, the test level could be higher depending upon what the exact application or what the threat level is there. And if we combine the DO160 requirements with some of the requirements which are called out by MIL standard 464C, in some cases the requirements go as high as 7,000 volts per meter in the high frequency range of around I believe 13 or 14 gigahertz range. However, that's called out by MIL standard 464C, which is more of the military non-commercial aircraft application basically. While we are on the topic of the radiated susceptibility, I want to take a slight deviation here and quickly jump into how the radiated susceptibility testing is done in the industry. There are two main methods. One is the absorbent line fully anechoic chamber, where using the high power amplifier, people will generate the field strength required for the entire frequency range. Now, considering what the size of the EUT may be, especially if the EUT size is larger and the high frequencies above 1 gigahertz, there may be need to do multiple antenna positions to cover the entire face of the EUT. Thus, by doing so, that could take much longer to perform the testing, and at the same time, to generate the higher field strengths, the amplifier power is outrageously higher, and high power amplifier poses so many challenges: the input power, the issues with the heating up of the amplifier itself, the cabling mechanism, the antennas. So the whole thing becomes a huge challenge. There are other approaches which are approved by the standard like DO160, MIL standard 461, some of the commercial automotive standard as well, which is the use of the reverberation chamber. On my slide, you guys can see a typical setup of a reverberation chamber where it could have up to 2 tuners. Some cases people can add more tuners as need may be. However, generally speaking, there will be a tuner for the vertical orientation and one for the horizontal orientation, and with the use of these tuners, higher modes of the RF energy could be introduced into the chamber. What we do in this case is, as I have indicated on my next slide, that using the cavity resonance phenomena and relying upon the reflections from the wall from the reverberation chamber, we try to generate higher modes, and these modes, when strategically positioned with the use of the tuners, can give rise to very, very high field with relatively very little amplifier power. And as these fields are generated based on the Q factor very uniformly, therefore we can test much larger EUT without the need of doing multiple antenna position, and we can not only reduce the test time, we can improve the efficiency of the overall testing and increase the testing experience. where with the absorbable line method, the concern could be certain portion of the EUT may be exposed to higher field strengths compared to the other, especially if the EUT is a larger system, whereas with the reverberation method, the entire EUT will be like it is immersed in a uniform field of the RF energy, and therefore we can have a much better understanding and indication of the behavior of the EUT when the EUT or the device under test will be exposed to the field strength, applicable field strength. The reverberation chambers not only help with the radiation susceptibility testing, it's a great opportunity to cover many other standards which are requested for and directly related to the avionics standards and MIL standard 461. There are requirements for cable shielding effectiveness testing. There are requirements for material shielding effectiveness testing, absorber testing. We talked about the DO 160 requirements, the requirements for HIRO testing or HIRF testing, which is basically testing for ordnance and testing for high frequency, very high frequency field strength testing. Met labs in our facility in Santa Clara, we recently added our reverberation chamber, which allows us to not only go all the way up to 40 gigahertz, but it allows us to meet the testing requirements for HIRO and HIRF testing as well. Finally, towards the end, I want to briefly talk about Section 22, which is the indirect lighting. The difference between Section 22 and 23 is that Section 22 obviously covers the indirect lighting, whereas Section 23 covers the direct lighting. With the indirect lighting, what we try to see is that when the lighting hits a structure, it's going to induce currents onto the power lines or other interfaces, which will then find their way into the electronics. How would the electronics behave? Question comes to mind, who will need this sort of testing, especially keeping in mind the lightning testing? So simply put, any aircraft or airframe manufacturer, I have listed some of the countries with the airline manufactured there. For example, Bombardier in Canada, talk about Airbus, talk about the Boeing, so on and so forth. Another challenge which comes to mind today, with keeping in mind the DO 160, especially with special focus on the lighting requirement, is that the trend in the industry is to make lighter aircrafts heavily relying, in other words, on the composite material. And a large number of these composite materials, by very definition, are non-metallic, and they do not provide the Faraday cage effect which one would get if the entire structure of the aircraft was made up of a good conducting material. Thereby, the use of technology to improve the aerodynamics, we are indirectly exposing the electronics inside a commercial aircraft to the phenomena like lightning, which can basically leave the electronics inside the aircraft more vulnerable. Therefore, there is an increased, enhanced need to more thoroughly test the avionics equipment to ensure that when these composite materials are used, they will not negatively impact the performance of these electronics and thus cause any sort of safety or hazard for the equipment being used, or cause any unsafe condition when the commercial aircraft is in flight. Section 22 covers a whole bunch of different waveforms. I have one slide which lists all those waveforms, but very briefly, there are 7 different waveforms. The test level can be as high as to level 5, which in other words is the highest level, and it is used when the concern is that the electronic equipment would be more exposed to these threats, or in other words, it would be used for the equipment which would have more sensitive nature, and the concern would be that it could lead to unsafe condition if the equipment malfunctions in one way, shape, or the form. 2 test types we talk about: pin injection, cable window, and there are 3 test methods: direct cable induction, and the ground induction. For the cable bundle test, it could be either done in a single stroke, where we just give a single spike. In multiple stroke, we can give multiple strokes and then stop the test. In the multiple bursts, we are injecting multiple bursts, like if you folks are familiar with the electrical fast transient-like test. So we are giving the burst of the fast transients. We are inducing those bursts of the fast transient onto the cables. When we talk about the lighting testing, typically the lighting testing comes in what we call cable category designations. What these category designations are that there are a bunch of waveforms for each one of those categories. For example, V3, G4, L3 would mean level 3, but the waveform set V, level 4, the waveform set G, and level 3 and waveform set L, which could be for all different categories of the EST test, all different categories of lighting testing being requested. Here's a brief summary of all the waveforms. Some of them are the current waveforms, some of them are the voltage waveform. I'm not going to spend too much time trying to describe what these waveforms are. They are self-explanatory. I just provided the summary here for the reference sake. Levels for the lighting testing, as I mentioned earlier, level 5 is the most stringent, for most critical equipment. Level 1 would mean that the equipment and wiring is installed in a very well protected environment, and level 2 to 3 and 4, depending upon the intermediate severity levels required. Folks, depending upon the limited time, I was not able to cover every single aspect of the EMI testing requested by the DO-160. I tried to cover some of the most critical parameters. We talked about DO-160, how it compares with the Eurocade requirements. We talked about some of the test levels. We spent a little bit more time on the lighting requirements, and we looked at some of the test methods there. So if you folks have any questions, which I was not able, or other aspect of the standard which I was not able to address due to the limitation on the time, please feel free to write a question now or send it by email, and myself or either one of my team member will get back to you with the answer to those questions as soon as possible. I hope you find this presentation useful. So at this point, I would like to thank you for your time and hand over the control back to Sarah. Sarah, back to you.
That concludes the presentation portion of this webinar. Tomorrow, an archived copy of this webinar will be available on metlabs.com. We will send a follow-up email with a link to this file. Now we will answer questions. If you have any questions, please type it in the questions area of your control panel. For questions we can easily address now, we will read the question aloud and then give the answer.
Okay, so one of the questions is that how often the lighting testing, the indirect lighting testing is requested. My response would be that for several years we have seen much larger interest by the manufacturer in the area in general. There's a large influx in the request for the indirect lighting testing, to the point that we decided to invest in two testers. One we keep in each one of our locations, one in Baltimore and one in California. So we are seeing an enhanced need of this sort of testing. There is one more question, which is that what cases the direct lighting is typically requested. So most of the time, the direct lighting would be requested for externally exposed components. For example, an antenna which will be externally mounted to a commercial aircraft. But keep in mind that the direct lighting testing can, by very definition, could be destructive. We've seen the horrific examples where when the directing testing signal were applied, and the equipment typically, the EUT practically shattered into pieces. There is one question, is that if we are running a program where there is a need to do MIL standard 461 testing and the DO 160 testing, are there at some parallels? And as we talked during the presentation, there are certainly parallels at many areas. For example, we talked about the audio frequency power testing, which is, I believe, section 18. So the test method there is practically similar to CS 101, which is from MIL standard 461. Then we talked about the parallels between RS 103 and the section 20 and the conductor susceptibility testing with CS 114. So yes, there are quite a bit of parallels, and if there's a need to look at that further in terms of reducing the cost, time to time we have these discussions, and where it's practical, where it makes sense, we work with our customers, we help prepare the test plans, and we help apply that knowledge to help reduce the test cost. One of the question is, how many samples need to be tested for EMC testing? So EMC testing for a large number of standards, same is the case with DO 160, where we'll be testing only one sample. There's another question, if the Boeing and Airbus have their own requirements. So one way to look at it is that that's very true. They do indeed have their own test requirements. However, for the large part, they are heavily based on the DO 160 requirements. One way to put, one more accurate way to put this would be that their requirements go above and beyond what would be required by a typical DO 160 program. Okay. There's one question about the current waveform and or the voltage waveform. So the way these waveforms are picked up, they are based on statistical studies done on various different commercial aircraft, on various different set of the avionics in different conditions. So based on the statistical data, what is observed is that if a waveform would be more prominent in terms of the current being induced, or it could be more in terms of the voltage being generated at the input terminals. So based on those statistics, the waveforms can or are characterized as either the current waveform or the voltage waveform. Another way to look at it is that if we draw a parallel with some of the commercial surge testing by 61004-5, it's called combination waveform, where the voltage aspect is defined as 1.2 by 50, where 1.25 microsecond is the right time, 50 microsecond is the time to the half. However, when you apply that signal into a short circuit, a current will be induced which will be 8 by 20 microsecond. So again, based on which factor will be more prominent, historically the standard writers will characterize those waveforms either as a current waveform or as a voltage waveform. Folks, that's all the questions I have so far. If there are other questions, please do send them to either Bernadette or Sarah from our marketing group, and they will pass them along to me, and myself and one of my team members, we will answer them and get them back to you as soon as possible. Sarah, back to you. Thank you.
As Assad said, if you have any additional unanswered questions, you may contact us via phone or email. Tomorrow we're also going to send out a follow-up email that will include a link to the presentation, and that includes our webinar. Thank you for joining us today.